Now we're going to talk about how and what happens the moment you type a URL. Okay, let's say you type www.youtube.com. We're going to understand how that URL is broken down and how it is routed to that request is routed to its destination and how you get your response back. So to understand this better, we'll be using a really interesting example. So let's start off with Jack Hoff Dragon Quest, of course. So your name is Jack Hoff, okay? You're the main character of the story, and you are the almighty messenger of the kingdom of YouTube land. So your mission is to give this dragon scroll to your master, who is Hugh Jazz. And but the problem is you are in Goa. You are enjoying your vacation, but you being you're workaholic and tied to your duty, you decide to head back home and give the dragon scroll to the inn or the hotel that your master is staying at right now. But then you get to thinking, and then you realize that you actually don't know your way back home. Then after that, you see that the dragon scroll consists of a key to finding your way back home. You decide to head to your home and have an amazing adventure. So before you get started, okay, you're gonna have to have a travel checklist. So let's make sure you have everything ready to hit the road. So there's the dragon scroll, of course, you need that. And every country needs a passport to get in, so you need that as well. And you need to know the name of the country. You do know that. So there is one thing that you need to know for sure. So that is the coordinates of every place, right? So every place has its own coordinates. So let's say you want to go to McDonald's, you would need its coordinates ideally. But nobody remembers these coordinates. They just kind of remember it along with the names and area names, right? So an area name is an alias for the actual underlying coordinates. So I just want to keep that in mind. Okay. Then you also need to know which gate number you're going to go to, because every country is going to have its own entrances, right? You can't enter just walk in without you know without any restriction. You have to enter through specific gates, go through specific verification processes. So that's why you need to know which gate you're going through. So that's your travel checklist. Before you head out, you do need to check a few things. Okay, let's say for argument's sake that you know you might have made a note of the location or the exact coordinates of YouTube land in your notebook. So you pull out your notebook and check it out, but then it turns out that is not there. So then you think that maybe just maybe I have it in my phone. So you open your phone and check it, but it's still not there. Then you give it your last shot by checking the hotel database. If maybe the hotel database is gonna have their location or coordinate put out there. In real world, that would be the case, but for the sake of the story, let's say that it's not there. Okay. So these are the list of things that you would do before even heading out. Okay, before even starting your journey. Okay, so let's get your journey started. Okay, before starting a journey, you need to first of all decide your mode of transportation. Right, that is your first thing. Let's assume that you have this mm, genie of an assistant, your personal assistant, who would actually go to the location, get the exact coordinates, come back to you and give it to you. But then this is too good to be true. So let's just discard that for now. So let's go in the idea that you are going there on your own. Okay, so you're using your transportation, you're going there on your own physically. You stop at the country gate. You stop at YouTube Kingdom's gate, and the security guards there ask you, which gate do you want to enter? Let's just say you say, I want to enter gate 80. Then they check your passport to see if you have the permissions to enter gate 80. Then they let you in. So then after you get in, then your first stop is to go to the kingdom's palace. Okay, so let's just say the kingdom's palace has a list of all the cities, all the places in the database. So you're gonna go to the Kingdom's Palace and you're gonna search for which city you want to go. Okay. There, after getting the city, you use your transportation device again and then go to the city. Okay. Then after going to the city, you go to the city hall's library. So let's just assume that this library has a list of all the areas and the records of all the areas ever existed in that country. Okay. So after you go into this library, you look for the rack. Uh, you look for the bookshelf that has the name of the place you want to go to. So let's say that you want to go to a hotel named YouTube Hotel. Okay. Then you would go to you would go to the rack which starts with Y, and then you would go to the section which starts with, which has the word YouTube or anything like that, and then you would pull out a book which will be the name of your hotel. In that book, there is one and only thing, and in that book there are the coordinates of um, your hotel. So let's go. You have finally found the coordinates of your hotel, the hotel that you would like to go to. Now you make a note of this, okay? And now the with this you can reach your destination, okay? Because this is a unique destination. Sorry, this is a unique value. So once you have this, it's pretty much like you've reached your destination. And there's another thing that I'd like to note. Let's say that there is a librarian who reads the books and updates the details every time a new book comes. Then let's just let's just keep that in mind, okay? And every book, in every book there are coordinates, right? But there are many types of coordinates as well. Let's assume that there is a 4 coordinate address and there is a 6 coordinate address, just because YouTube land is huge. Okay. Now let's go through another concept. There's something called, let's assume that there is a guide who would guide you at the gate of the city hall library, right from the gate till right from the city hall library to the hotel. So this guide would be called something in internet terms. We'll get back to that later. And you also have a hotel clerk who would take you to your master's room, because you wouldn't know where your master's room is. So that's what the hotel clerk would do, right? So let's go. You have completed your mission and you have handed over your scroll to your master, and you've saved the day. So this is the story. Okay. Now we'll get into how the actual URL works in real life. And we'll just have the screen open side by side so that we can compare. Okay, let's go. So now let's get into the actual part of this video. Okay. So let's assume that you enter a URL, say youtube.com, and the browser that you enter it into is going to split it into multiple components. Okay. There are 4 main components: scheme, secondary level domain, top level domain, and subdirectory. So these 4 components is gonna play multiple roles. Okay. So the scheme here, for instance, is gonna decide which port number you would like to go to, with you would like to send your data to. So let's say it's HTTP. HTTP will always, by default, use the port number 80. But if you say HTTPS, then the default port is going to be 443. What exactly is a port, you might ask? Do you remember we spoke about the gates in YouTube land? So those exactly are ports. So a port is like an entry point for web traffic to enter the server or the machine that's serving your web resources. That is the first thing. The second thing is a secondary level domain. Okay, you can think of this as an alias to the IP address of the server machine or the machine that you would like to access the resource from. Okay. Now, if we think about our story and relate the concept, this is like how we don't want to remember the coordinates of YouTube land. We just remember the name YouTube land. So we remember our destination name. And then we have the top level domain. This is like a city existing inside a country. Okay, so you're never going to have only one city, and that is there's nothing inside that. But you're going to have many cities inside countries and multiple areas inside a city. So for that reason, you need to have another domain level. Okay. Now you have the subdirectory. Subdirectory is like talking about which area you'd like to go to. And in web terms, it's like telling you which resource you would like to access. So let's say you want to access a specific resource like a profile page or a login page. So this is what determines that. So these are the basic URL components that you would have to keep in your mind. Let's move on to the next one. Okay, so here are some prerequisites. Okay, in order to understand the next section, you need to understand this. Okay, so port listening and web server. Okay, so web server is nothing but an application or a software application that exists on your machine or any machine, which constantly listens for web traffic on the ports HTTP and HTTPS, or rather port 80 and port 443. So it looks for traffic, and if any messages are incoming, then it processes that message and then it sends that message back to our application server. Now you might ask, what is an application server, right? So an application server is nothing but it's like the logic and the inner working of a website. So let's say that you want to get some static content to a web server, and that web server will pass it on to the application server. So in this case, the web server acts as a reverse proxy and the application server acts as a proxy. By proxy, I mean that to the external world, it looks like the files are sent directly to the application server. So yeah, like I said, an application server conducts a lot of things like database lookups, user sessions, custom API, and a few of the example frameworks are Node.js, Django, and also Ruby on Rails. So it's gonna help you to basically communicate with your client and get the static content from the web server. And once you get static content, you apply your business logic. So the application server applies your business logic, it re-renders the static content and then sends it back to the client. So by doing so, you can make sure that all the business logic is implemented and you also get dynamic data. So that's a little bit of about application servers. So now let's go on to the next concept. So there's something called HSTS policy enforcement. Okay. First of all, HSTS is nothing but HTTP strict transport security. So do you remember we spoke about the passport verification at the gate of YouTube land? So this is exactly that. So HSTS policy enforcement is a list of domains that must always be accessed over HTTPS. A list of domains that must always be accessed over a secure way of communication. So HTTPS is nothing but HTTP but secure. So meaning that it should always be accessed through port number 443. So if in case you do try to access it using HTTP port, so the role of this component is to convert the HTTP that you typed into HTTPS before it even goes to the network. So this is the role of HSTS policy enforcement. Well, before we go onto the network, so we need to perform a few checks. Okay. So these checks are called cache level lookups. So there are three main types of lookups. The first one is a browser level cache. Second one is an OS level cache, and the third one here is, well, third one is supposed to be a DNS cache, but I haven't mentioned it here. But yeah. So first of all, the browser level cache is the cache that is there locally in your browser. So it stores a list of all the recently accessed IP addresses, so that it's easier to look up. And you have something called the stub resolver. So this is like your OS level cache. So in your operating system as well, before going to the network, it's going to check your operating system cache. If the cache is a hit, then that means that you don't even have to go to the network to find the IP address. You just have it available there and you can directly use it. And all the web requests, and you can access the ports directly using that cache. So that's a little bit about your browser cache and OS level cache. So that's what happens here. So first of all, you check your notebook. This would be the browser level cache. Then you check your phone. This would be the stub resolver. And if you check your hotel database, that could be your DNS cache. So our first part of the URL resolution is done, meaning that we found which port number to target. Now the second part is finding the domain name. So right now we have an alias in as the domain name, that is youtube.com. So we need to find the actual IP address using this domain name. So here is when the DNS resolver process comes. So in the DNS resolver process, there are three main domains. So the first one is a root name server, or rather the root zone. The second one is the top level name servers or top level zone. And the last one is the authoritative name servers. So these three name servers can be closely related to our example here. So let's say that our Kingdom Palace sits on the top. Kingdom Palace sits on the top, and that is the root server. Then you have the City Hall Library, which is the top level domain. And lastly, you have the authoritative name servers, which is nothing but your rack of books, which consists of all the domains. So you're going to have to find your domain in one of these books, or in one of these racks of books. So what's the first thing you do, right? So now we know that there are three types of zones. The root zone is the topmost layer, okay? Everything below that is what our suffix of the domain is. That is .com or .org or .edu. So when the DNS resolver requests the root name server for a specific suffix, so it will give us the list of top level domains, and under that list it will give us .com because we are trying to reach youtube.com. Then the DNS resolver will request the .com name servers for youtube.com. So this will go inside the rack and it'll pick out the book that says youtube.com. And it's important to note that the authoritative name servers will always have the IP address. So this is the last level, or this is the last layer. You can't go further. There is nothing within a book other than the coordinates or the IP address. Also, another thing to note is that in real life, you have the authoritative zone, right? So within the authoritative zone, you have something called zone files. So this is the file where you enter details like what is the domain name, what are the subdomains that come under it, and what is the IP address for that domain. So you have a lot of types of attributes that can be entered here. Some of them are the A type and the AAAA type of an IP address, or you have the C name for aliases and MX for mail. So all you need to know is that these are the types of domain names or IP addresses that can be entered. There's another thing that I'd like you to know is the domain registrar. So domain registrar is kind of that librarian that I talked about earlier. So the librarian is nobody but a person who maintains all the records, maintains all the books in the correct order. So similarly, a domain registrar is an entity where you can register domains. Let's say you want your own domain. You would go to a domain registrar like GoDaddy or Namecheap, or you can even go to Google Domains, and they will update the TLD registry with your domain's authoritative NS records. So if you look at the diagram, you this is the layer in which the uh, websites like GoDaddy work. So they are accredited by the government and they will update it for you and you will be able to have your own domain. So now we come to the most important part of this educational episode. So here we have a diagram of how recursive resolution works. Okay. So first of all, you have the requesting host. So that is this. So this is nothing but us as a client. We are requesting for web resources from a server. So first of all, we request a DNS resolver. A DNS resolver is usually provided by your internet service provider. So this is always of the type recursive DNS resolver. It's nothing recursive, just simply means that the DNS resolver will completely take care of finding your IP address and returning the IP address back to you. But in an iterative DNS resolver, you might have to manually look for it in the different zones. For example, first of all, you have to go to the root zone, see if your domain exists there. If not, come back, go to the TLD server, then come back, then go to the authoritative DNS server, and then get your IP address. However, the recursive DNS server is the most practical use of this. So once you give the request for your website, it goes to it it goes to the it first goes to the root DNS server. Then the root DNS server is gonna go to the TLD DNS server based on the request. So since it's uh, .com, it would go to the .com domain, and the TLD DNS server would then go to the authoritative DNS server. So once we reach the authoritative DNS server, we would have the IP address for sure. Then this is returned back to the TLD, then return back to the root, and then return back to the DNS. And ideally, we end up with the IP address. So at this stage, now we have nearly everything that we need to access our server. So we know which port number we would like to access. So we want to access port 80, so HTTPS, and then we have the IP address. So it'll be HTTPS um, colon slash slash, and then the IP address along with the port number. So once we enter this, well, once we enter our domain name, all this happens in the background in an instant, and then we get the resources from the web server or the target server, and the web server returns back the static resources. This can be viewed to us using a browser. So in this case, the browser works like a middleman for doing all these things in the background. So the browser is the entity that processes your URL. It identifies where to send it and which server to get the information from, and serves the web content to you in the form of HTML or CSS. So that's how a recursive DNS works. So just to summarize, if we were to relate this whole concept with our little story here, so this is like you going to, so from the DNS server, this is like you going to the kingdom's palace, and then you're going to the city hall library, and then you're going to access the rack of books, and then you get the book, and you get the final coordinates of YouTube land. So that's how you could relate this and that. So hopefully that gives you a better idea. So then we come to the last part of this cycle. So after all this is done, when we send out a request to the server, so you would have to connect using the TCP connection. So the TCP connection establishment has three main steps. First, the client would send a synchronous bit to the server. the server will send back a synchronous bit with an acknowledgement saying that ready to connect. This is my confirmation. And then the client has to send back an acknowledgement bit. So after this, a TCP connection is going to be made, and this will be active for as long as needed. So this is the process of TCP connection establishment. So let's just go through one last thing about how these pieces fit together. Okay. First of all, you get your URL. Okay. Your URL has four main components: the scheme, host, port, and path, or path rather resource. Okay. So your scheme is the HTTPS. The host is your domain name, that is youtube.com, and your path or resource is your, well, the feature that you'd like to access, like login, profile, etc. Then the browser enforces the HSTS rules. Okay, so it'll check to see if it is supposed to be HSTS certified, and then it'll add the HTTPS and make sure that it only accesses this through the secured port, and then it will directly send it to the internet. So then the browser also, before sending it to the internet, the browser also checks it if it's in the cache, and if it's not, then the OS level cache is also looked up. So the DNS resolver will go to the root, okay, then it'll go to the TLD, finally to the authoritative servers with registrar involvement to get the host IP. After the browser completes the TCP three-way handshake, we have established a complete connection between the client and the server. So at this point, static content can be sent and received as much as needed. The web server here, so like I said before, the use of the web server is to send static resources from one server to another client, or a client to a server. So it's there in all of our computers. It's required. Or if it's not in our computers, then it's going to be on our browsers. So browsers use technology extensively. So you have tools like Apache or Nginx. So these are web server examples. And app server, like we said, it runs the code. It kind of acts like a proxy server when you want to run your business logic. So yeah, that's pretty much it. This covers your entire flow of how what happens when you type the URL. So yes, I hope this helped. Please don't subscribe.